Okay, good evening. Okay, last time we have discussed about some applications about dimension analysis. Accordingly, we have discussed about the first application. What is that? Determination of accuracy of an equation. In that case, if we are given an equation, and if we are asked to determine the accuracy of this equation, what we should do is we have to take dimensions of each sides. That means we have to take dimension of LHS and RHS. If both sides have same dimension, we can say this equation is dimensionally correct. If they do not have same dimension, definitely we can say this equation is incorrect. Because if there is an equation, both sides should have same physical quantity. As example, if this physical quantity is a velocity, this one should also a velocity. Okay, so both sides should have same physical quantity. Okay, so in the equation, LHS and RH sides should have same dimension. If not, definitely we can say this equation is incorrect. But as we discussed earlier, there's a limitation. There is a limitation in this analysis. What is that, Puta? Can anyone say what is the limitation of this analysis? Give me answer.
We can only say that it's dimensionally correct.
Yes, because if we when we are analyzing this equation, and if we find the dimension of LHS is equal to the dimension of RHS, we cannot say this equation is 100% correct. We cannot say that now. Okay, actually I have given an example mentioning that. Okay, we cannot say this equation is 100% correct, but we can say this equation is dimensionally correct, Puta. That means the dimension of LHS is equal to dimension of RHS. That means the physical quantity represented by LHS is equal to the physical quantity represented by RHS. Okay, so in this analysis, we can only say this equation is dimensionally correct. That is the limitation. We cannot assure this equation is 100% correct. But if it is wrong, obviously we can say this equation is incorrect. Okay. Okay. During this analysis, we have learned some factor. That is, if there is an addition or subtraction, both physical quantities may combine with addition or subtraction should have same dimension. Okay. Accordingly, each and every terms in an equation each and every terms in an equation should have same dimension. What is a term? What is a term, Puta? Can anyone say? What is a term? How to identify a term? How to identify a term? Huh? Terms are connected with plus and minus signs, Puta. As example, AB plus PQ over Z equal RT over P plus Q minus R. Suppose there's an equation something like this. Terms are the things connected with plus or minus signs. Plus or minus signs. Accordingly, this plus sign belongs to this one and this one. This thing and this thing. Okay. So this is a term. This is a term. Okay. This minus sign belongs to this part and this part. So this is a term and this is a term. This is a term. Okay. Do you understand what is a term? Can you understand that term? Please give me a yes.
Yes, sir.
Okay. This is a okay. So if there's an equation, each and every term in an equation should have same dimension. Each and every term in an equation should have same dimension. Okay. Okay. Let's do some example. Can you see my screen? Okay. I will do first two questions. I will do first two questions with you, okay? Determine whether the following equations are correct or not. The physical quantities represented by the symbols are given below. So these are the symbols, okay? Okay. The first equation is S equal ut plus half at square. S equal ut plus half at square. Okay, don't do anything. I will explain how to do that. Okay. Okay. This is the equation. No, Puta. That power is electrical power. P equal VI means it is a power generation by a electrical charge. Okay, not a mechanical power. P equal VI. We cannot use P equal VI for mechanical power. Okay. Okay. Good question. Okay. Shall you do this question? Okay. We are asked to determine whether this equation is correct or not. Okay. Now this is the equation. First, we have to determine, or we have to take the dimension of LHS. We have to take the dimension of LHS first, LHS or RHS, whatever the things. Okay. In LHS, S is a displacement. Displacement means it is a length, Puta. It is a length. So the dimension of displacement is equal to L1. Then RHS, dimension of RHS is equal to the dimension of UT and dimension of AT square. AT square. Don't write this one. Okay. Dimension of RHS. Dimension of RHS. You have to take dimension of each and every term separately. Each and every term separately. So dimension of UT. Dimension of UT. You have to take the dimension of UT first. You have to take dimension of UT first. U means it is a velocity. T means it is a time. It is a time. So what is the dimension of velocity, Puta? I think now you can remember that one. What is the dimension of velocity? Velocity? Tell me. Dimension of velocity. Oh, katawal. Dimension of velocity. What is the dimension of velocity? Velocity.
LT minus 1.
LT minus 1. Good. LT minus 1. LT minus 1 into T. Into T. Okay. T minus 1 to T plus 1 will be cancelled out. So this is equal to L. The second one. Now the LHS, the dimension of LHS is equal to L, and dimension of the first term in RHS is equal to L2. Okay. Then the dimension of second term. Dimension of second term in RHS site. That is AT square. AT square. So dimension of AT squared is equal to the dimension of A and dimension of T squared. Dimension of A means it is acceleration. The dimension of acceleration is equal LT minus 2 Puta into dimension of time is square. That means T is square. So T minus 2, T plus 2 will be cancelled out. So this is equal to L. Sorry. This is equal to L2. Okay. Then we can say something like this. From the equation number 1, 2, and 3. 1, 2, and 3. From 1, 2, and 3, we can say each and every terms in this equation, each and every term of this equation have same dimension. Therefore, this equation is dimensionally correct. So, I can write this one. Therefore, each and every terms in this equation have same dimension. Therefore, this equation is dimensionally correct. Dimensionally correct. This is the sentence we have to write. Okay, this is the sentence we have to write. If all the terms, if each and every terms have same dimension, then we should write this one. We should write that argument. Okay, what is that? Each and every terms in this equation have same dimension. Then we can say this equation is dimensionally correct. This equation is dimensionally correct. Okay. Suppose something like this. If we are given here ut, but here at, not at square. If we are given ut here, but at here, not at square. If it is not at square, then this term, the dimension of this term is not equal to the dimension of other terms. Okay, then we can say the dimension of at is not equal to the dimension of other terms. Therefore, the dimension of each and every terms of this equation do not have same dimension. Okay, then we can say this equation is incorrect. This equation is incorrect. Okay, that is the way of doing this kind of question. Okay, do you understand, Puta? Everyone? Everyone? If you understand, please give me a thumb. Good. Others? Okay. Shall we do the questions now? Okay. You have to write the first example as in the board. You have to write the first example. Then from second question, from second to 10th question, from second question to 10th question, you should do now. First write the first example and do the others. Once you finish this one, please give me a thumb. I want to check your answers, okay? Once you finish the work, if possible, please upload your answers to the tutor uploading group, okay? Then I can check your answers. Okay, I want to check your answers. because this is not a MCQ question. So I need to check the way you read the question. Yeah, up to question number 10, Puta. Up to question number 10. In this page, now I have done the question number 1. All the other questions, that's mean question number 2 to question number 10, you have to do. Okay. Okay. Have you done up to question number 5, Puta? Okay. Then can you please could you please send your answers to me? If you did if you did up to question number 5, please upload your answers, okay? Then I can discuss. Spring constant means puta, last time we did that thing. Spring constant equal to spring constant is equal to force divided by length. Force divided by length. Okay. That's mean, suppose if there is a spring, if there is a spring, and if I apply a force on this spring, the length of this spring will be increased. No, the length of this spring will be increased. Okay. This increased length is the length is the length here, and apply force is the force here. Putave, Diary name, your name? When you are writing the answer, you have to write the logic to each and every terms. If each and every terms, if the dimension of each and every terms is same, you should write that one. That is the logic. Okay, that's the logic. According to that logic, you can say this equation is dimensionally correct. Okay. Then if there are two terms with different dimensions, you should mention that term. Each and every terms in the equation do not have same dimension, so this is dimensionally incorrect equation. That is the way of writing. Okay. Question number 5, Diani. Question number 5. Could you please check the dimension of K? That's mean spring constant. Please recheck that one. Spring constant. I think it should be ML the spring constant. The spring constant is MT minus 2. MT minus 2. No? Everyone, when we are writing, okay, everyone, please stop your work and look at the box. Okay. When you are writing the logic, please write that down. Don't write the final answer. Don't write the final answer only. Okay. That's mean if you are given if A equal MA, if you are given F equal MA, we can find the dimension of LHS. That is equal MLT minus 2. Then we can find the dimension of RHS. That is MLT minus 2. Then we can say each and every terms of this equation have same dimension. So this equation is dimensionally correct. Suppose we have this kind of equation. V squared equal U plus 2as. In this case, you know the dimension of LHS. Dimension of LHS equal L squared t to the power minus 2. Then dimension of U is equal LT minus 1. Dimension of U, LT minus 1. Okay. Then Puta, you after that you can find the dimension of this one too. After finding this one, you can say the dimensions of each and every terms in this equation. Each and every terms of this equation do not have same dimension. So this equation is incorrect one. Okay. You have to write that logic. What is that logic? Each and every term in an equation should have a same dimension. If the equation is correct, each and every terms in that equation should have same dimension. That is the logic, Puta. Okay. According to that logic, you should determine whether the equation is correct or not. Okay. I think it is better to write that not. Okay. Not tag to the liagan not. Take not tag to the dagam. Not. Okay. I will check, Puta. I will check. Okay. Okay. Not tag to the dagam. If an equation is dimensionally correct, if an equation is dimensionally correct, each and every terms in that equation, should have same dimension. Not 76876. Is that Diniti?
Yes, sir.
Okay. Dua me look at your question number 3. Question number 3, Buta. RHS, you have taken the dimension of u square. So LT minus 1 square. LT minus 1 square means L square into T minus 2, L square. It should be L square, not L. Or L to the power 2. It should be L to the power 2, Buta.
Okay, sir.
Then again, AS, 2AS. You have taken the dimension of 2AS. The dimension of A Puta LT minus 2, that is correct. Dimension of S, L, that is correct. And you have cancelled out L and L. You cannot do that. L into L means L is square. L square Puta. ඒක හදාගන්න.
Okay, sir.
When the equation is dimensionally incorrect, you can directly say, Puta, this equation is incorrect. Okay? You can directly say this equation is incorrect, because if it is correct, dimensions of all the terms should be same. Okay? If it is not, you can directly say it is not correct. Okay? Not dimensionally incorrect. Okay? Dimensional incorrect කියලා ලියන්න අවශ්‍යතාවයක් නැහැ. කෙලින්ම incorrect කියලා ලියන්න. ඒක අවුලක් නැහැ. Dimensional incorrect ඕනේ නැහැ. හරි? Yeah, good. Good. Steve, mx squared means put the one term, okay? In question number 4, f equal mx squared. Mx squared means put the one term. Do not may take m separately, x square separately. Do not take that one, okay? In here, there is no plus or minus sign. There is no plus or minus sign. So there's only one term, that is mx squared. There's only one term, Puta. Okay? F equal mx squared. Okay? So in right hand side, there's only one term. Only one term. This is a term. Okay? Do you understand me, Puta? Steve?
Yes, sir.
So do not separate m and x squared. Okay, do not separate that thing. Okay, you have to take the dimension of mx squared at first. Mx squared, dimension of mx squared. Okay, please correct that one. Please correct that one, Puta. Okay, other things are okay. Sure. Nusra, do don't write the equation is dimensionally incorrect. If the dimensions of each and every terms are not same, then you can say this equation is incorrect. This is incorrect. Okay? Incorrect නම් කෙලින්ම incorrect කියලා කියන්න පුළුවන්. Okay, good. Okay, good. Yes. Yeah. Okay. In this kind of equation, Puta, in this kind of equation, suppose f equal mx squared, there are only two terms in two sides. That means all one term in left hand side and other term is right hand side. Then definitely you can simply get the dimension of LHS, blah 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 blah, then dimension of RHS. You can simply take that one. If they are same, then you can say dimension of RHS equal dimension of LHS, then equation is dimensionally correct. If they are not same, then you can say dimension of RHS unequal to dimension of LHS. So the equation is incorrect. That means if they are same, you can write dimension of LHS equal dimension of RHS. Therefore, this equation is dimensionally correct. Dimensionally correct. Okay. If not, you can write dimension of LHS is unequal dimension of RHS. So this equation is incorrect. So this equation is incorrect. you can use this kind of narration too. This kind of narration too. That is okay. Okay. Because in this case there are only two terms in two sides. That means one term in left hand side and other one term is right hand side. So there are no any addition or subtraction. There are no any addition or subtraction. So we don't want to consider each and every terms in this kind of equation. Okay. Okay, I will explain to that. I will explain. Okay. Question number 2. Question number 2. V equal u plus 80. I think that is okay for all of them, all of you. Question number 3. Question number 3. V equal u squared plus 2s. V equal u squared plus 2as. That is question number 3. Okay. Shall we do that? This is our question. Then I can write the dimension of LHS, that is equal to dimension of V. V is a velocity, so dimension of LHS equal LT minus 1. Then we can consider dimension of RHS. First, you have to, there are two terms, Buddha. There are two terms. There are two terms in RHS. So you have to consider each and every term separately. Each and every term separately. Okay. U squared. Dimension of U is squared. U means a velocity. So dimension of U squared means dimension of U into the power 2. Into the power 2. So dimension of U means dimension of velocity. Dimension of velocity is equal to LT minus 1 into the power 2. Into the power 2. So then we can write L t to the power minus 1 into the power 2 means L is squared t to the power minus 2. You have to multiply both powers. Okay. This is second one. Then you have to take the dimension of A into S. A into S. You don't want to consider 2 because 2 is a number, no? 2 is a number. So you don't want to consider that number. So dimension of A into S is equal dimension of A into dimension of S. A is a acceleration. A is acceleration. S is a displacement. If A is acceleration, then the dimension of acceleration is L t minus 2 and dimension of S is L. Dimension of S is L. So this will become L into L means L is squared t minus 2. L is squared t minus 2. Okay. In here, these two have same dimension. These two have same dimension, but LHS have different dimension. LHS have a different dimension. So the dimension of LHS is not equal to dimension of RHS. Or in other words, you can say each and every terms of this equation do not have same dimension. Therefore, this equation is incorrect. Therefore, this equation is incorrect. Okay. Do you understand, Pudha? It's true.
Okay, sir.
Mx square. F equal mx square. Fourth one. F equal mx square. Fifth one, F equal kx. Sixth one, equal mg v. mgv. Okay. In here, there are only two terms. There are only two terms in each side. So definitely you can simply take the dimension of LHS and dimension of RHS. Then you can compare the difference between LHS and RHS. Okay. Dimension of LHS. LHS in here, it is a force. So dimension of LHS is MLT minus 2. Then dimension of RHS. dimension of RHS equal to dimension of mx square. This is a single term, Puta. This is a single term, okay? Because there's no any addition or subtraction, okay? If there are multiple terms, there should be an addition. There should be additions or subtractions. Okay. In here, no addition and no subtraction. So it is a single term. M. Dimension of M into dimension of x squared. Dimension of M. It is a mass. X is a displacement. So L square. From 1 and 2, we can say dimension of RHS. Dimension of RHS unequal to the dimension of LHS. Therefore, the equation is incorrect. The equation is incorrect. Do not write dimensionally incorrect, okay? Because if it is incorrect, we can directly say, we can say exactly say this equation is incorrect. Okay. Then this one. Dimension of LHS. It is a force, Puta. It is a force. So dimension of LHS is MLT minus 2. MLT minus 2. Then dimension of RHS. Dimension of RHS is equal to dimension of Kx. K means spring constant. I think you can remember the dimension of spring constant. That is equal to MT minus 2. MT minus 2 into L. L means dimension of X. Dimension of X. So in here, we'll find MLT minus 2. From 1 and 2, I can say dimension of LHS is equal to dimension of RHS. Because there are only two terms. There are only two terms means one term in LHS and one term in RHS. So we don't want to consider each and every single terms because there is only one term in LHS and one term in RHS. So we can simply determine the dimension of LHS and dimension of RHS. Then we can say, therefore, this equation is dimensionally correct. Dimensionally correct. If the dimension of two sides are equal, we should say this equation is dimensionally correct. Dimensionally. Because we cannot distinguish whether this equation is actually correct or not. We cannot distinguish that one. Because we do not know if there is any numerical value, if there is any numerical multiplication with this equation, we cannot determine that value. We cannot determine the dimension of that value. Okay. That is the reason. Okay. Then E equal mgv. E equal mgv. Dimension of LHS. Dimension of LHS equal dimension of E. Dimension of E. E means energy. Energy. ML square T minus 2 dimension of energy. Then dimension of RHS. Dimension of RHS equal dimension of M, G, V. That means dimension of M into dimension of G into dimension of V. Dimension of V. Dimension of M. M is a mass, so dimension of M is equal to M. And G is a gravitational acceleration. Gravitational acceleration means it is an acceleration, Buddha. So the dimension of acceleration is LT minus 2. Then dimension of V. Dimension of V means velocity. LT minus 1. Then we can simplify this one. M. There are two L's. There are two L's means L is squared. And T to the power minus 2 with T to the power minus 1. That means T to the power minus 3. Then we can say the dimension of RHS. The dimension of RHS unequal to the dimension of LHS. To the dimension of LHS. From that, we can say this equation is so this equation is incorrect. Incorrect. Okay. Okay. Do you understand this one? Good. Fifth one, S equals U plus V over 2 into 2. Seventh one. S equal U plus V over 2 into T. Eighth one, P equal F. Ninth one, P equal F x over T. X over T. Okay. Shall we do this? In here, there's a plus sign. There's a plus sign. That's mean there are two terms. There are two terms, and we have to consider those two terms separately. S equal UT over 2 plus VT over 2. I have expand this brackets. Okay. Then dimension of LHS. Dimension of LHS equal dimension of S. Then that is equal. S means it is a length. It's a length. Then dimension of RHS. There are two terms. One is Vt over 2. Other one is Ut over 2. Dimension of Ut over 2. That is equal to dimension of U into dimension of T. Dimension of U into dimension of T. Dimension of U, it is a velocity. So dimension of U is equal to LT minus 1 puta. Then T is a time. You have to multiply this one by time. T minus 1 to T will be cancelled out. Answer is L. Answer is L. Then you have to consider the dimension of Vt over 2. Vt over 2 means it is equal to dimension of V into dimension of T. Again, the same calculation. V is a velocity, so dimension of V means Lt minus 1. T is a time, so minus T to plus T will be cancelled out, equal to L. Then you can say each and every terms in this equation have same dimension. So this equation is dimensionally correct. This equation is dimensionally correct. This one. LHS. Dimension of LHS. That is equal to dimension of power. What is the dimension of power, Puta? Dimension of power. Yeah? Dimension of power equal to
ml2 t minus 3.
ml2 t minus 3, no? Power. Energy over time. Energy over time. Then dimension of RHS. It is equal to the dimension of force into dimension of velocity. Dimension of force is mlt minus 2. Dimension of force is equal to mlt minus 2, and dimension of velocity is equal to lt minus 1. Lt minus 1. So we can simplify this one. There is only one m here, but there are two l's here, and minus 2 minus 1 means minus 3. Minus 3. Okay, from that we can say the dimension of LHS. Dimension of LHS equal to dimension of RHS. Both have same dimension. Then we can say this equation is dimensionally correct. This equation is dimensionally correct. Then the ninth one. Dimension of LHS equal dimension of power. Dimension of power, you know this one. ml squared t minus 3. ml squared 3 minus 3. Then dimension of RHS. Dimension of RHS. Dimension of RHS equal dimension of RHS, that is equal to dimension of force, dimension of x over dimension of time. Dimension of force, that is equal to mlt minus 2. Dimension of x means it is a length, so we have to multiply this one by L over time. Then this is equal m L, there are two L's, L squared, then t minus 2, and there's a t, If I bring this t to the numerator, it will be minus 3, minus 2, minus 1. So minus 1 into minus 2 is minus 3. From here, I can say the dimension of LHS. Dimension of LHS equal dimension of RHS. That means this equation is dimensionally correct. Okay. Do you understand this one? Do you understand this one up to now? Good. Others? Everyone? If you want to explain it again, I will explain it. Okay. Very good. Good. Okay, Puta. Because now I have to go to another part. Another part. Okay. We have learned how to determine the accuracy of an equation using dimensional analysis. So that is the first application of the dimensional analysis. Okay. The second application is, suppose we are given an equation. We are given an equation with non-physical quantities and several unknown physical quantities. With known and unknown physical quantities. And we are asked to find the dimension of that unknown physical quantities using the non-physical quantity. Okay. That means we are given an equation with non-physical quantities and unknown physical quantities and asked to find the dimensions of unknown physical quantities. Then we should learn how to determine the dimension of unknown physical quantity in an equation. Okay, so that is the second application of dimensional analysis. Okay, write down as a topic. Second application. Determine the dimensions of unknown physical quantities in an equation. Determine the dimensions of unknown physical quantities in an equation. Okay. Suppose we are given this kind of equation. F equal kx. I think we know this equation now. Suppose we are given this kind of equation and they said F is a force and K is a displacement. If F is a force and K is a displacement, find the dimension of K. Find the dimension of K. How to find that one, Puta? How to find that one? Anyone suggest us way? How to find the dimension of K if we are given the dimensions of F and X? How to find that one? Propose karano? Yes, that is the easiest way. First, we have to subject the K. We have to subject K. Yes, subject it. If we are given F and X, if we are given F and X, and asked to find the dimension of K, we have to subject K first. Then we can apply each dimension of each and every term in that equation. So in here, K is equal F over X, then we can apply the dimension of K is equal to dimension of F over dimension of X. So dimension of M is MLT minus 2 over L. So MT minus 2. Very easy, no? Very easy. But the thing is, we are not given this kind of equations. Normally, those equations will be much complicated than this. Okay. Suppose, let's assume another example. Let's take another example, okay? This kind of dot. F equal K plus half AT square. You are given S is a displacement and A is a acceleration and T is a time. Then you have to find the dimension of K. How to find that one? Can anyone propose a way, propose a method? Yeah, na. Answer ka din. Huwag ka rin method na propose ka. Kung may lamay tika. Please give me an answer. You are given S, A, and T and asked to find the dimension of K. Now everything you have. How to find the dimension of K? Come on, Karan. If you have any logic or any argument, please let me know. No. Then, yeah, making the K subject by subjecting. Alright. So find the dimension of K and let me know. Take a rough sheet and find the dimension of K. Quickly tell me the dimension of K. Quickly. You can determine the dimension of K without doing any calculation. Without doing any calculation. No, Puta. Yeah. How do you get that one? By subjecting. Your answer is correct. Okay. Actually, there is a logic. There's a logic. You know, if this equation is dimensionally correct. Actually, this is dimensionally correct equation, no? Okay. If this equation is dimensionally correct, each and every term should have same dimension. You know that one. According to that logic, K should have the dimension of S. K should have the dimension of S. Because according to our logic, if the equation is correct, each and every terms have same dimension. Puta. Another logic. If according to this logic, K should have the dimension of S. Do you understand? Everyone? Okay. Steve? Nushra? Do you understand, Puta? Diniti? Diniti? Do you understand? Okay. What is our logic? Sorry. What is our logic, Puta? According to our previous explanations, if the equation is if there is a correct equation, if there is a correct equation, each and every term of this equation should have same dimension. According to that logic, the dimension of K should be equal to the dimension of S. Dimension of K should be equal to the dimension of S. What is the reason? What's the reason? Because each and every term in an equation should have same dimension. Each and every term in an equation should have same dimension. That is the logic. So the dimension of K should be equal to L then. Okay. That is one way. Okay. Actually, if we are given this kind of equations, if we are given this kind of equation, it is very easy because we can subject the particular physical quantity and apply the dimensions of others. But we are not given this kind of this kind of simple equations. Normally, we are given very complex equations. Okay. So there are some factors to be considered during the determination of dimensions of unknown physical quantity. Okay. One factor is this. What is that factor? If there is an equation, what is that factor? Factor number one. What is that factor? If there is an equation, Puta, if there is an equation, each and every term of this equation should have same dimension. Okay. According to that logic, according to that argument, you can simply determine the dimension of K. You don't want to calculate this one. Okay. You don't want to subject it. Okay. So no, you cannot do subjecting K. You cannot do subjecting K because there is an addition. No, there's an addition. There are two different terms. No, not different terms, but there are two terms you cannot subject here. That is the thing. Okay, you cannot subject here. You cannot subject here. You can take this argument only. Okay. You cannot subject this one. You cannot subject. You can, but the thing is, when subjecting this one, you will have S minus something. That is meaningless, Buddha. That is meaningless. Okay. S minus this thing. But we are taking the dimensions, not a value. Okay. If you want to find a numerical value for K, then you can subject. No? If you want to find the numerical value, suppose this is 5, this is 10, and you want to find the numerical value for K, then you can subject K. But now we are taking the dimensions of K. So subjecting here is meaningless. It's meaningless. Okay. Don't do that. Okay. In here, you have to consider the argument of each and every terms of this equation should have same dimension. That is the argument. Okay. You should consider that argument. According to that argument, you can determine the dimension of this kind of unknown physical quantity. Okay. So this is the first factor to be determined, to be considered during this analysis. Okay. Okay. You have to write the topic. Topic is determination of dimensions. Determination of dimensions of unknown physical quantity in an equation. I think you did that one, no? Okay. Under that topic, like this one. If we are given an equation if we are given an equation with unknown physical quantities, and asked to find the dimensions of them.
Sir, can you repeat it from the beginning?
If we are given an equation, if we are given an equation with unknown physical quantities, with unknown physical quantities, and asked to find the dimensions of them, we have to utilize some theories, some concepts. We have to utilize some concepts. In dimensional analysis, we have to utilize some concepts in dimensional analysis. To determine them. Okay. You can write these two examples. You can write these two examples. Example number 1 and example number 2. Okay. Okay, write this one under these two examples. Therefore, there are few factors. There are few factors to be determined, to be considered. There are few factors to be considered. There are few factors to be considered during this analysis. During this analysis. Okay. All right. Okay. Write a subtopic. Write a subtopic. Factors to be considered. Factors to be considered. Okay. හොඳයි පුතා. දැන් මේ ටික තමයි මේක හොඳටම බලා ගන්න ඕන ටික. මේ factors මොනවද කියන එක. First factor. In here, the first factor is each and every term in an equation should have same dimension. That is the first factor to be considered during this analysis. Okay. Normally, we are not given very simple equations. Normally, we are given some kind of complex equations. So, we have to consider these factors. Definitely, we have to consider these factors. So, the first factor is each and every term in an equation should have same dimension. Should have same dimension. Okay. That is the first factor to be considered. This one. Write down. First factor is each and every term in an equation should have same dimension. Same dimension. You can write the previous example, no? S equal K plus half AT squared. So, the dimension of S should be equal to the dimension of K. Example 1. Example 2. Suppose no. If they ask to find dimension of unknown physical quantity, definitely we should have a correct equation. Okay. Therefore, definitely it is a correct equation. Otherwise, we cannot find the dimension. No? Suppose this kind of equation. In here, Puta, S is a displacement and V is a velocity and T is a time. Okay. In this equation, okay, look at this, everyone. In this equation, S is a displacement, V is a velocity, T is a time. We are asked to find the dimension of A, K, and B. You are asked to find the dimensions of A, K, and B. Can you do subjecting now? This is the question. S over A minus K equal V plus BT. Here S is a displacement, V is a velocity, T is a time, and find the dimensions of A, K, and B. A, K, and B. ටක් ගාලා කරලා මට අප්ලෝඩ් කරන්න. ටක් ගාලා කරලා ෆොටෝ එක අප්ලෝඩ් කරන්න. In here, you have to use the same argument, okay? What is the argument? Each and every term of an equation should have same dimension. Each and every term in an equation should have same dimension. That is the argument. In here, S is a displacement, V is a velocity, T is a time. Okay. මාත් එක්ක කරමුද? Have you done this one? Anyone? Or do you want more time? ඔය කට්ටිය සද්දයක් නැහැනේ. කරාද? Okay. Thank you. Good. Your answers are correct. Your answers are correct. Very good. Okay. Others? Okay. Shall we do together? Okay, Buta. In here, there's a one term, and that is the answer. In here, Puta, actually in here, there are 4 terms, no? In here, there are 4 terms. 1, 2, 3, 4. Among that 4 terms, there is a one term that is the answer. What is that? There's a one term that is the answer. Mokaddi. What is that?
Velocity.
Velocity. Very good. Very good. Because in here, velocity is the non-physical quantity. It is the non-physical quantity. Therefore, each and every term should be a velocity. Should have the dimension of velocity. That is our point. That is our argument. So what is our argument? What is our argument? The dimension of velocity. The dimension of velocity should be the dimension of k, no? Dimension of k. So, okay. We will write this. According to our previous argument, each and every term of this equation should have same dimension. So, S over A, dimension of S over A should be equal to the dimension of K. Those are terms, no? Then this should be equal to the dimension of V, dimension, okay? Not the value. That should be equal to the dimension of Vt. Dimension of Vt, okay? What is the argument? Because each and every term in an equation should have same dimension. Should have same dimension. That is our logic. Then there is a non-one. There's a non-one. What is that? Velocity. So all those terms should be a velocity. Okay. So there's a non-one, Puta. that is velocity. From that, we can give our answers. So, directly we can say the dimension of K is equal to dimension of V, that is LT minus 1. LT minus 1. Okay. Then, dimension of S over dimension of A is equal to dimension of V, that is equal LT minus 1. LT minus 1. So, dimension of A is equal, what is that? Dimension of S means L. Dimension of S means L puta, L over LT minus 1. Cross product, okay? Cross product. L to L will be cancelled out, then this one should be T. T. Okay. Then BT. So dimension of B into dimension of T should be equal to the dimension of V. Dimension of V. So dimension of T should be equal LT, sorry, dimension of B, okay? Dimension of B should be equal LT minus 1 over T. LT minus 1 over T. Here T, no? This is a time, so dimension of time is equal to T. Here LT minus 1. So if a subject be LT minus 1 over T. LT minus 1 over T. So dimension of B is equal LT minus 2. Everyone, do you get my point? Do you get my point, Puta? Everyone. Very good. Others? Nushra? Very good, Steve. Nushra, do you get my point, Puta? Do you understand? Okay, thank you. I will explain again. Okay. Okay, Puta. Look at this. First thing you should know, if there's an equation, each and every term should be the same physical quantity, no? Because we cannot add or subtract two different physical quantity. Okay, can you add time to a kilogram? You cannot add time to a kilogram, no? So you cannot add or subtract two different physical quantities. So if there is an equation, each and every term should have same physical quantities. That means same dimensions. Okay, because we can add or subtract same physical quantities. We cannot add or subtract two different physical quantities. That thing you should know first. Okay. According to that logic, each and every term in an equation should have same physical quantity, should have same dimension. Okay. In here, there are four terms, Budame. This is a one term. This is another term. This is another term. This is another term. There are four terms. So the dimensions of each and every term should be equal. Dimension of each and every term should be equal. That is our logic. Then we have to determine the dimension. No? Then we should find a way. We should find a way. In here, we know this thing. We know this thing because we are given this is as a velocity. So we know this thing, Puta. So if it is a velocity, each and every term in this equation should be a velocity. Okay. So this one should be a velocity, this one should be a velocity, and this one should be a velocity. Okay. Accordingly, then dimension of V should be equal to the dimension of K. Okay. So dimension of K is equal to the dimension of V, that is LT minus 1. Then this one, dimension of S over A should be equal to the dimension of V. Dimension of V means LT minus 1, Bhuta. So we know the dimension of S means that is a length, it is equal to L. So there is L, there is LT minus 1. If we subject the dimension of A, we will find L over LT minus 1. L to L will be cancelled out. There is T minus 1. So if I bring this one to the numerator, it will be plus T minus 30. Then the last one, BT. This term should also a velocity. So B in dimension of B into dimension of T should be equal to dimension of V, because this is a velocity. So this is a velocity, this is a time. If I subject B is equal LT minus 1 over T. So if I bring this one to the numerator, it will become LT minus 2. Okay. Now, Nusra, do you get my point? Okay, good. Okay, Bhuta. Then, shall we do some examples? Okay. Shall we do the question? Shall we do first 5 questions? First 5 questions. Do it quickly. Once you complete up to 5, please may upload your answers. H is a height, Puta. H is a height, okay? In third question, X is a distance. Fourth question, S is a displacement. U is a velocity. A, acceleration, T time.
So what is X in the third one?
X is the distance, Puta. Distance. Up to 5, okay? Do in third question. Third question, there is x squared, no? Therefore, you are in your answers, it should be L squared. No? Right hand side, denominator, it should be L squared. Okay? No. Okay. Karo meka. හොඳයි. හොඳයි. බලන්න මේ විදිහකට කරමු. First one, f equal mx. F equal mg. Okay. Everyone now stop your works and look at this, okay? If there is any mistakes or any anything you have done wrongly, please correct the things. First thing, this one. So, according to that, the dimension of M should be equal dimension of M into dimension of Z. Okay. Okay. Sorry. Then dimension of F means MLT minus 2, MLT minus 2 equal dimension of M means capital M into Z dimension of Z. Then M to M will be cancelled out, Puta. M to M will be cancelled out. Then I will have the dimension of Z is equal to LT minus 2. LT minus 2. If you have any mistake, please correct that thing. Second one. Second things, equal ZGH equal ZGH. H is a displacement, is a energy. So dimension of E equal dimension of Z into dimension of G into dimension of H. So after that, you have to apply dimension of each and every term, each and every physical quantity. E m L square T minus 2 is equal dimension of Ez into dimension of D means L T minus 2, L T minus 2, and dimension of H means L. Dimension of H means L. Okay. Then I can write this one again, or you can do your memory. This one, L and L. There are two L's. That means L squared and T minus 2, T minus 2. Then in right hand side there is L squared, left hand side there is N squared, sorry, squared, L squared will be cancelled out. T to the power minus 2, T to the power minus 2 will be cancelled out. Then the dimension of Ez is equal M. Okay. Then third dot. F equal G M1 M2 over R squared, X squared, no? X is a displacement, okay? X is a displacement. So F, dimension of F is equal to dimension of G into dimension of M1 into dimension of M2 over dimension of X to the power 2. X to the power 2, okay? Then you can replace them. Dimension of F is equal M L T minus 2. So dimension of G equal here. This is a mass and this also mass. Mass into mass means M into M over L. This is a displacement, so it is L. L to the power 2 means L squared. So 1M will be cancelled out with 1M. Then if I subject G, M here, there's a M, so it will become minus M, L to the power 2, L to the power 1, that's mean L to the power 3, T to the power minus 2. Make out this one.
Yes, sir.
Okay, very good. Then බලන්න ඊළඟ ගාන කරන්න හැටි පුතේ. The next question, you have to clearly understand how to do the next question. Everyone, please look at this. Everyone, Stop your work and please look at this. S equal U Z plus half AT squared. S equal U Z plus half AT squared. Okay. In this case, Puta, you don't want to expand each and every term. Okay. You know, if it is an equation, each and every term should have same dimension. Again and again, I'm saying this one. Each and every term should have same dimension, Puta. So dimension of S should be equal to dimension of U is it. That's only. You have to write that's only. Okay. What is that? S U dimension of S should be equal to the dimension of U is it. No? Do you understand me? This one. Do you understand, Puta? Do you get my point?
Yes.
Really? Do you get my point? Okay, don't expand this one, Puta. Okay? So, but you have to write the logic. You have to write the argument under this expression. What is that? Each and every term in an equation should have same dimension. Each and every term in an equation should have same dimension, because each and every term in an equation should have same dimension. You should write this one. Okay, that is the logic. Okay, you have to write each and every logic in your answers, because these are not MCQ question. So you have to write each and every logic in your answers. Now you can simplify this one. Now you can simplify this one. Now you can subject. Is it? No? So the dimension of Z is equal to dimension of S over dimension of U then, no? Dimension of S. Dimension of S. S means S is a distance, displacement. So the dimension of displacement is equal to L, and U is a velocity. Dimension of velocity is equal to LT minus 1. LT minus 1. So L to L will be cancelled out. The dimension of Z is equal to T. Okay. Don't expand each and every term. Don't expand each and every term. Do not apply dimensions of each and every physical quantity here. Don't do that, because that is not the answer. Okay, that is not the answer. That is not the logic. In here, the logic is, if it is an equation, each and every term should have same dimension. Okay, then take the easiest non-physical quantity, easiest one. In here, you know half AT squared. You know each and every physical quantity here, but it is not an easy one. In here, this is the easiest physical quantity. This is the easiest non-physical quantity, Buddha. Okay, take that one, and you can equalize the dimension of S and U is set here. Okay. So after that, you have to write the logic, then you can subject is it. Okay. If you are not writing in this way, please use this way. Please use this way. Fifth one, v equal y plus 80, no? V equal y plus 80. Fifth one, same scenario. V equal y plus 80. How to do that? Now you have to tell me how to do that. Steve, can you explain me? Can you explain me?
The dimension of y is equal to the dimension of velocity.
Very good. Others, is that correct? Is that correct? Yeah, your answer is correct. What is the answer? According to our previous logic, if it is an equation, each and every term should have same dimension. So dimension of y should be equal to dimension of v. Dimension of v. So simply we can say the dimension of v should be equal to dimension of y. Dimension of y. After that, you have to write the argument here. Argument. What is the argument? Because each and every term in an equation should have same dimension. That is our argument. So dimension of y is equal, then LT minus 1. It is equal to the dimension of velocity. Do you get my point?
Yes, sir.
Very good. Okay. Now we have learned the first factor. The first factor to be considered in this analysis. Okay. Then the second factor. Then the second factor. Then the second factor. Second factor is Puta. If there is a plus, if there are two physical quantities, if there are two physical quantities combined with an addition or subtraction, if there are two physical quantities combined with addition or subtraction, both should have same dimension. Both should have same dimension. Okay, that is our second factor. That is actually that is the same thing in as in first factor, but I want to write it as a separate factors. I will explain what is the reason in later. Okay, so what is the second factor to be considered in this analysis? If there are two physical quantities, combined with an addition or subtraction, both should have same dimension. Same dimension. Write down that one. Write down that one. Factor number two. Factor number two. If there are two physical quantities, combine with combining with an addition or subtraction, an addition or subtraction, an addition or subtraction both should have same dimensions. Both should have same dimensions. Both should have same dimensions. As an example, if there are two physical quantities A and B combining with plus or minus, then the dimension of A should be equal to the dimension of B. That is the second factor. Third dot. මේක දාගන්න example එක. මේ example එක දාගන්න. Okay. Actually, we have already discussed about other factors. Other two factors. That is power and logarithm functions. Power and logarithm functions. I think we have discussed them under the topic of units. Okay. Okay. As we discussed earlier, we know if there is a power, something like y to the power z. If there is a power, what the power p or something. If there is a power, Puta, this should be a number. A power should be a number. A power should be a number. Okay. So, if there is a power in an expression, this power does not have a dimension because it is just a number. It is just a number. Numbers do not have dimension. Okay. So numbers are only numbers. No, they are not physical quantities. Numbers are not physical quantities. So they do not have dimension. So if there is a power, power is just a number, so it doesn't have a dimension. It doesn't have a dimension. Okay. That means the dimension of that power is equal to 1. Equal to 1. Okay. I think you can remember this one. Okay. Do you remember this one? We have done this one. Do you get my point, Puta?
Sir, should y also be a number?
Sorry?
Is it necessary for y to be a number?
No. It is not necessary y to be a number. But power should be a number. No? Power represents the number of times. Number of times multiply this y with its own value. Okay. So this is just a number of times That means that actually that's a number. Okay. Y may be a physical quantity or any other things. Okay. So, but power should be a number. Power should be a number. Okay. Do you get my point? History? Okay. This one may be a physical quantity, Buddha. This one may be a physical quantity. Okay. But I'm saying about this one. Power. Power just a number. Power represents the number of times this has been multiplied by its own value. Okay. So power is represent a number of time. It's just a number. Okay. Okay. So if there's an expression something like this, suppose A equal B to the power Cx plus D. Cx plus D. Suppose we are given this kind of expression. A equal B to the power Cx plus D. Cx plus D. So according to our logic, Cx plus D is a number. It is a number because this is a power, no? This is the power. Cx plus D is the power. Cx plus D is a power. It's a power. Therefore, it is a number. It is a number. Therefore, it doesn't have a dimension. It doesn't have a dimension. So I can say the dimension of Cx plus D, Cx plus D should be equal to 1. Should be equal to 1. Should be equal to 1. That means this is a dimensionless quantity. Then I can use my previous factor, that is, if it is an equation, both terms should have, so each and every term should have same dimension. So if it is a number, if it is a dimensionless quantity, each and every physical quantities should be dimensionless. Dimensionless. So the dimension of D should be equal to 1 and dimension of Cx should be equal to 1. Should be equal to 1. Do you understand this one? Do you understand this one? What is my argument? What is my argument? My first argument is this one, because Cx plus D is a power. This is a power, Puta. If it is a power, it is a number. It is just a number. So the dimension of power is equal to 1. That means it doesn't have a dimension. Then I can apply my first factor. What is that? If there is an equation, each and every term should have same dimension. Each and every term should have same dimension. Here, right-hand side does not have dimension. So left-hand side should not have dimension too. So there are two terms in left-hand side. There are two terms in left-hand side. So each and every term should not have dimension. So dimension of D should be equal to 1. Dimension of Cx should be equal to 1. Do you understand this one? මේක තමයි මෙතන තියෙන ඒ කියන්නේ වැදගත්ම කැලල. Do you understand this one? Steve?
Sir, can you explain the last part again?
Sorry, පුතා. This one? No?
The last part.
Okay,
Yes, sir.
I will explain. Up to this one, you know? Up to this one?
Yes, sir.
Okay. Shall we write this one? Up to this one. Okay. Okay, our third factor. Third factor. The power of any base. The power of any base is just a number. Is just a number. Therefore, any expression therefore any expression in a power, any expression in a power does not have a dimension. Does not have a dimension. Does not have a dimension. You can write up this one. You can write up to this one. Okay, up to this one. Okay. Right under this, right under this. Right under this. As this is an as this is an equation, as this is an equation, as this is an equation, right under this, okay, right under this, as this is an equation, as this is an equation, each and every term should have same dimension. Each and every term should have same dimension. Each and every term should have same dimension. Okay. Okay. According to that argument, Puta, each and every term should have same dimension. As this is an equation, each and every term should have same dimension. So Cx is a one term. So dimension of Cx should be equal to the dimension of D. Dimension of D. And it should be equal to the dimension of this side. It should be equal to the dimension of this side. So what is the dimension of this side? It is 1. It is 1. Dimensionless. Dimensionless. Do you understand issue? Each and every term should be same. Each and every term should have same dimension. So dimension of Cx should be equal to the dimension of D. It should be equal to the dimension of this one. As this is a number, dimension of this one is 1. Then, therefore, dimension of D is equal to 1. Dimension of Cx equal to 1. Equal to 1. That means dimension of C is equal to 1 over dimension of X. 1 over dimension of X. Do you get my point?
Yes, sir.
Very good. Okay. Okay. Time is up. Do you have any doubt or do you have anything to ask about today's lesson? Or do you clear with that? Do you understand that one?
Sir, are these the only 3 factors to be considered?
Sorry?
Are these the only 3 factors?
No. There are 2 others. There are 2 others, but I will teach that one in Sunday's class. One is logarithm function. I think you can understand that one. Logarithm functions. Other one is trigonometric functions. Okay. I will do that in Sunday's class. Okay. Then after that we can complete our tut. Okay. Okay. So we can complete our today's class, Buta. Do you have any question? Do you have any question? Don't try to do these questions. No. You can try up to question number 14. You can try up to question number 14 now, okay? Try out that one. Up to question number 14. You can do up to question number 14 and upload your answers to the tube uploading group. Okay. Now you can do up to question number 14 here and upload your answers to the tube uploading group. Okay. I will check that one. Okay. Okay, Buta. Then everyone, good night, and we can complete our class now. Okay. God bless you.
Thank you, sir. God bless.